thank you for the introduction. Can you hear me? Or I try to speak loud. As was mentioned, I'm one of 4 partners and founders of Soma. We're an Austrian office, and we are based in Vienna. And I'm not only going to talk about the kinetic facade we did together with Knippers Herwig for the Expo 2012, but I would like to show you the overall design, because we evolved the facade really out of the architecture, and we did not start with the idea of a moving facade, but it came out of the process. This is the site and the building. We won the competition in October 2009, and we were completely under shock. This has not changed since then, I have to say, and it's quite interesting how much time you spend on what in these projects. It took us 3 months to get a contract, and then we had 6 months for the planning phase. So for everything until the construction document. So this was quite interesting to rush this project through and still try to follow an innovation and an investigation. And probably that's also the great part about these projects, that they enable you to work with these great engineers. It was not only Knippers Herwig from Stuttgart, but also Transolar from Munich, and this was really a pleasure to work with them on such a high level. So this is the official Expo rendering. It shows the situation on site with our building implemented already. As you can see, we build into the open water, and this promenade will be erected. Actually, it's already being under construction. And the harbor is a former industrial area that's completely transformed now into a new city part. And most of the pavilions are temporary, but our building is one of the permanent ones. So that was also, of course, very important, that you have to think of an after use that's not even decided yet, because they have to sell the building afterwards. So this was really also a tricky part. So the initial idea of the design was to work with the coastline, since the coastline for the Koreans is really very much something they identify with, and this whole coastline is already completely artificial. We wanted to emphasize this and combine artificial and natural parts along this coastline by aggregating exhibition spaces and creating this new coastline there. And this was the main idea of these interrelated exhibition cones that are then transformed to open up these public spaces in the foyer that is an extension of the promenade. And these cones frame the view into the ocean. The other idea of the design was to work with surfaces that transform from the vertical to the horizontal and twist. And by that they create different spaces, and they communicate between the flatness and the depth. So we had 2 exhibitions in the building. One is a thematic exhibition, which is a virtual multimedia show, needs to have a black box, and one is a flexible daylight exhibition where institutions and universities present scientific research. So these exhibition cones twist from these vertical spaces you immerse into with a striking height into the flat platform of the best practice area, which is more flexible and has daylight, and also gives you the connections down again to the foyer. And here you see the view from the foyer, and see how you immerse into these deep spaces. And also, of course, these twisting surfaces appear on the outside, and this is a model of the final design. And there's the shaded entrance area, and as every one of you who has been at an expo knows, the expo is not about exhibition, it's mostly about queuing. So this is really the most important part. Yeah, again, this idea of this one surface that divides, defines, and separates in one time the main spaces of the building to create this continuity. And of course, in section, when you deal with continuity, you have a transformation. So you see here how one surface is first a thick wall of concrete and then turns into these platforms to come back over the facade of the kinetic facade into the structure of the roof and the roof gardens on top. And of course, we had to have a change of materials then in the end. So these seams get very important. And in ground plan, you see again the idea of the merging cones that create these platforms and this topography. So the idea, first of all, on the side, we had two very different situations. We had the open water and the water basin that is calm water, and of course you have to protect also the building from the seawater and from the waves. So this idea of this two-sidedness came up very early. And this is the competition stage with a solid appearance with these the cones facing the water and protecting the building, and then towards the water basin, this landscape with this fragile facade that is walkable. So the roof gets a part of the exhibition, like a next floor you can enter without waiting. This is competition stage, and that's a rendering with that we went to Knippershelvig. And as you can see, we had ideas or aspirations how the facade should look like. So it should be something seamless, something smoothly swaying, something without hinges, not mechanical, rather organic. But what you can also see from this rendering is that we had no clue how to materialize it, or even in the 3D model. It was really tricky. We had this miracle material in mind that could do everything. And then we went to Knippershelvig, and then they said, well, you know, that material exists. Yeah, it's no problem for us at all. And I think that is really what was a great part to work with them, because they're really design sensitive. And I think that's so crucial when you work with these great engineers, that they understand the concept and they have the same aim. And although they have a completely different approach, probably that's what this push and pull game is, what you then start, but you have the shared goal. And what was really amazing is then a few weeks later they sent us these photos they did in their office, and we were really impressed on what basis we met. I mean, it's a paper strip, and in this picture they really show the principle, and it's really simple. So it's a GFRP, glass fiber reinforced polymer lamella that is held on 4 points. And by moving 2 points and reducing the distance between those 2 points, the lamella makes a side rotation. And because it's elastic, deformable, and reversible in this deformation, it makes a very complex and beautiful movement. It needs no hinges, no local hinges. It has very low energy. It needs very low energy to be moved. And for us, it was just a very elegant and beautiful solution. I mean, I have to say, we worked through this. They proposed various variations, and in the end, that's what came out. But yeah, we are very happy with that. So again, the lamella. So these are the actuators that are on the bottom and the top level of the lamella and move the whole blade. And in section you see this is a cross section, this side rotation, the lamella moving outwards. So every lamella follows the same radius. We have over 100 lamellas, and they are between 3 meters and 13 meters long. And 125 meters wide. And here again you see the incredible, beautiful movement that just comes out of a material performance. So also the shape and everything comes from this. And what is interesting is that it looked almost like the competition entry, because of course when you work with these 3D modeling tools, they have this intelligence already incorporated, and no wonder that the geometry then can also work like that. So here you see the elevations of the lamella moving. and in ground plan. When in a top view, you see the side rotation. And through this side rotation, the lamella opens.